In this video, we are going to see calculate the electric field strength of the space wave which is received by the receiving antenna. Okay, for this we are taking the two antennas. One is transmitting antenna and the receiving antenna. This is considered as the height of the transmitting antenna, and this is considered as the height of the receiving antenna, HT and HR. Okay, then the wave that is getting transmitted by the transmitter will be received at the receiver through two paths. One is the direct path, which is nothing but the LOS path, and the other one we call this as R1, and the other one is the reflected path, which is getting reflected by the ground, from the ground. Okay, so this path we call it as R2, or we can say the distance traveled by this path R1 is D1, and this distance that is covered by the path 2 is nothing but D2. Okay, if that is the case, then we are about to find what is the electric field strength that is received at the receiver. The electric field strength is nothing, it is the total sum of these two electric field strengths, the vector sum of these two electric field strengths. That means the electric field that is obtained from the electromagnetic wave propagating through the direct path, and the electric field strength which is nothing but E2. This, let us say it as E1, this is say it as E2. Okay, it is the vector sum of E1 and E2. So what is the total electric field that is received at the receiver is, it is nothing but vector sum of E1 and E2. E1, let us say E1 is nothing but E0. E0 is the electric field strength at the receiver which is obtained through the direct path. And how to write the expression for the E2? E2 is nothing but the reflected wave, right? The reflected wave has a certain phase difference with when you compare with the direct wave. Okay, so now in order to write the expression of the electric field strength of E2, we can write in terms of E0, which is nothing but E1. Okay, it is equal, I can write like this, E0 into e power j theta. Okay, E0 is nothing but the electric field strength which is propagated through the path 1, and E0 into e power j theta is the electric field strength which is due to path 2. Okay, so what is this theta? There will be certain certain phase difference between path 1 and path 2, right? So that phase difference we are writing it as theta. Okay, so what is the total phase difference between the two paths now? The total phase difference depends upon the angle alpha and also another angle beta. I will say what is alpha and beta. Okay, the angle alpha is nothing but the phase difference that is created due to the path difference between these two paths. Okay, that means path difference between these two paths is nothing but d2 minus d1. Okay, this is D2 and this is D1. Because of the existence of the path difference between these two vectors, there will exist a certain phase difference. Okay, so what is the phase difference? Phase difference is nothing but path difference into 2 pi by lambda. Okay, so this is the angle alpha, and because this path 2 is having, it is nothing but the reflected ray, when compared with the direct ray, it has 180 degrees phase reversal. Okay, so this has an extra phase difference. This path 2 is having a extra phase difference of 180 degrees. Okay, so now the total phase difference between the path 1 and path 2 electric fields is nothing but the sum of the phase difference due to the path difference and the 180 degrees actual phase reversal because of the reflection that is happening. Okay, this is direct wave and this is reflected wave. Always reflected wave will have 180 degrees phase difference when you compare with the direct wave. Okay, so now the angle is nothing but alpha plus beta. So in order, now our aim is to find out what is this total phase difference, so that we can substitute here and get the final value of the electric field strength at the receiver. So in order to find that, we need to know the actual value of the path difference D2 and D1. So in order to get the values of D1 and D2, let us try to construct the small triangles Okay, so this is one triangle. Let us say this is say it as T prime, and this is T, this is R prime, and this is R, and we will say this point as M prime. Okay, now consider the triangle T prime, M prime, and R prime. Okay, if you consider this triangle, this is a right angle triangle. So what is this distance? This distance is nothing but this total distance minus this distance, right? So that means this distance is nothing but HT minus HR, right? So this is HT minus HR, and this distance, let us say this distance is nothing but the D. Okay, so this distance is D, and what is this one? This is actually D1. So we have all the three sides. According to the Pythagoras theorem, I can write it as hypotenuse square, which is nothing but D1 square, is equal to D1 square is equal to HT minus HR whole square plus D square. What is HT minus HR whole square? What is HT minus HR whole square? It is nothing but HT square minus HR square. Okay, I can write this like this. Okay, D1 square is nothing but 1 plus HT minus HR by D whole square. I can write like this. So what is D1? It is nothing but under root of 1 plus HT minus HR by D whole square, which is nothing but D into under root of 1 plus HT minus HR by D whole square. Is it not? Okay. Now I can simplify this expression. This is looking like this, the formula 1 plus this is x, okay, x power n. What is the formula of x power n? It is nothing but 1 plus n into x plus n into n minus 1 into x square by 2 factorial, and so on, right? So here n is nothing but it is power 1 by 2, right? N is nothing but 1 by 2 and x is nothing but this value. So I can simplify up to 2 terms. Okay, so d1 is nothing but d into 1 plus x. Okay, 1 plus n is 1 by 2. Okay, the power is 1 by 2. And what is x? HT minus HR by d whole square. HT plus HR minus whole square. And yeah, only up to 2 terms we are approximating. So now what is the value? It is nothing but d plus d into d square. So it will become 1 by 2d HT minus HR whole square. Okay, so this is nothing but d1. Now in the similar way we can obtain the path d2. Okay, so here in order to calculate d2, which is nothing but this distance plus this distance, I am trying to take a mirror image of this receiving antenna height. This also is the HR. Okay, this height is HR. We see this path, this total path we can obtain from this. If we extend this line, okay, and we consider this triangle which is nothing but T prime B A. Okay, this is the triangle. Okay, and this distance is nothing but this path distance, and this distance is always same. So what is d2? It is nothing but this entire distance from here to here. Okay, so d2 I can write like this. This is entirely from here to here, it is d2. Okay, so what considering the from the triangle T prime B and A, I can write again the same using the right angle triangle Pythagoras theorem. I can write d2 square d2 square is equal to, what is this one? This plus this is nothing but HR, right? So it is nothing but HT plus HR. This entire distance is HT plus HR. This entire distance, this is HT, this is HR. Okay, so HT plus HR whole square plus what is this? This distance is nothing but D. Okay, so it is D square. So d2 square is equal to this one. And if you simplify in the same terms, in the similar way, if you simplify, then we will get the d2 square as d square into 1 plus ht plus hr whole square by d square Okay, and you simplify like this, you will be getting d2 as d plus 1 by t2. So d2 I can write in the similar way that I have written d1 as d plus 1 by 2d into ht plus hr. Here the term is ht plus hr. Okay, whole square. Okay, so we got the value of d1, we got the value of d2. Now all we have to get is the path difference d2 minus d1. Okay, so what is path difference d2 minus d1? d2 minus d1 is nothing but d2 minus d1 is nothing but this value minus this value, okay, which is nothing but d plus ht plus hr whole square by 2d minus d plus ht minus hr whole square by 2d. Okay, if you this and this gets cancelled, ht plus hr whole square minus ht minus hr whole square by 2d. Okay, this is nothing but we'll be getting 4ht hr by, because a plus b whole square minus a minus b whole square, which is nothing but 4ab, 4ht hr by 2d, which is nothing but 2ht hr by d. Okay, if you know the path difference, then what is the phase difference? Alpha is equal to d2 minus d1 into 2 pi by lambda. Okay, 2 pi by lambda, which is nothing but 2ht hr by d into 2 pi by lambda, which is nothing but 4ht hr pi by lambda d is your path difference. Okay, now the total phase difference is this 4ht hr pi by lambda d plus beta, which is nothing but 180 degrees. Okay, so now we will go back to the electric field expression. E is equal to E naught into 1 plus e power j theta. Okay, let us find out the simplified expression for this electric field. Okay, so let us take E naught as common, 1 plus E into E plus j theta. E power j theta, we already know that it is nothing but cos theta plus j sin theta. If you do it, you will be getting it as 1 plus cos theta plus j sin theta. Okay, but and we need the magnitude of the E. So writing the real part and the imaginary part and taking the square root, we'll be getting the expression as x square plus y square. This is x and this is y. So it is 1 plus cos theta square plus sin theta square. If you do that, we will be getting it as 1 plus cos square theta plus 2 cos theta plus sin square theta. Okay, 1 cos square theta plus sin square theta is 1. 1 plus 1 is 2. It is nothing but 2 plus 2 cos theta, which is nothing but 2 plus, I am writing the cos theta here as 2 cos square theta by 2 minus 1. Okay, I am writing here cos theta as 2 cos square theta by 2 minus 1. If I write like this, then I will get the expression as 2 plus 4 cos square theta by 2 minus 2. Okay, so this 2 and this 2 gets cancelled. You will be getting an expression of under root of 4 is 2. So 2 E naught into cos theta by 2. Okay, so now here we have to substitute what is theta. Theta is nothing but theta is nothing but this value. This value is theta. So magnitude of E equal to 2 E naught into cos of theta by 2. So what is theta here? Theta is nothing but this one. By 2 becomes 2ht hr pi by lambda d plus 180 by 2 becomes 90 degrees. Okay, so cos 90 plus theta is always sin theta. So 2 E naught sin of theta is this one. So it is 2ht hr pi by lambda d. Okay, so always the heights of the antennas is always less than the distance between the two stations, transmitting and the receiving stations. This D is large enough when compared to the heights of the antenna. So we always take this product HT and HR is less than always less than D. So if D is very large, then the value within that sign becomes very small, right? So for the smaller angles of sign, we can write sin theta approximated to theta. So I am writing this expression for this condition, this expression as 2 E naught into 2ht HR pi by lambda d. Okay, so this and also we have to let E naught is equal to 7 under root P by D, where P is nothing but the transmitted power, D is nothing but the distance between the transmitter and the receiver. It is nothing but 4 E naught HT HR pi by lambda d, where E naught is nothing but 4 into 7 under root P by D HT HR into pi by lambda d. Okay, so what you, if you simplify this pi value 4 sevens and d square here, you will be getting an expression like this: 88 under root P, 88 under root P, this is gone, this is gone, this is gone. Okay, 88 under root P HT HR by lambda d square. Okay, this is the overall expression for the electric field strength. Okay, so based on this we have a problem. Okay, based on this we have a problem in the let me show you that problem also. Okay, based on this we have a problem here. This is a 5 marks problem which I have given in the CAT exam. So this problem involves LOS distance formula, which we have covered in the previous video, which is nothing but 4.12 into under root of HT plus HR, and the electric field expression, okay, which is nothing but 88 under root P HT HR by lambda d square. Okay, so these two formulas you try to remember and then apply in this problem, you will get the answer. Okay, so try to do the problem on your own. The solution is available here.